This is yet another seminar in an ongoing seminar series that we have here at the Energy Policy Institute at the University of Chicago. So many of you have been to some of these before, but for those of you who have not, just a quick word of introduction on what EPIC is. We are an applied research center within the University of Chicago, and the office here is an India group with most people working on India or Asia related research. So by applied research, I mean that a lot of our work is in partnership with policymakers or government and is attempting to solve a problem of immediate policy interest, but something that is also at the cutting edge of research in public policy or economics or engineering. So we try and mix both those two together, and that's sort of the work we do. As part of trying to be an academic and policy group here, we have a regular seminar series, and Jatin is going to give a talk as part of that. So we have an interdisciplinary group of speakers, everything from economists to public health people to environmental journalists. So we've had a wide range of speakers over time, and we do this about twice a month. So let me quickly get to today's talk. Jatin is the CEO and founder of SkyMet Weather, and this is a private sector initiative basically looking at weather forecasting and information services relating to weather forecasting, monsoon forecasting, and the like. So this is a company that has solutions and work in sectors as varied as energy, monsoon prediction, shipping, crop insurance is an important part of their work, and so Jatin will talk about this in more detail. He has a master's degree from Boston University and has also worked as a journalist with Aaj Tak and Headlines Today as a producer.
Hi, thanks everyone. Thanks for the opportunity. I should also give a little bit of context. So before we started talking and I came here, I was asked, what could we talk about? So I said, I wrote about 5 lines and I said, the politics of meteorological measurement is what I would like to talk about. And I'm not going to talk about what SkyMet does specifically, but before I start this, I should kind of give you how we have come here. So SkyMet is a agri and weather solutions company, which is more like, I don't know if you've heard of an American company called Climate Corp. So it provides solutions around climate. Everything from observations to forecasting to agriculture measurements to imaging satellites, analytics, and more and more fintech tools like credit scores for farmers, as well as underwriting both loans and insurance.
Financial technology.
Yes. So that is the breadth of things we do. We are about 264 people. We've been around for 14 years, and I would like to kind of put that away. But anyway, this is more from an academic interest, as I have seen things happen, and I would like to talk about it. You'll get more context by the end of this. So without taking more time, I shall talk about the obvious. So about 35% of India's GNP comes from agriculture. The numbers vary, but indirectly about 70% of the population is still agriculture dependent. 60% of our agriculture is rain-fed. And our economy, even today, even though you're led by service sector, everybody looks at monsoon, and it's a freebie that seems to reflect in every sector of the economy, from cements to motorcycles. Indian agriculture, agri-commodities and stock markets are very El Nino sensitive. And we've known this and we've seen this and we've felt this in the past decade or so. Food prices can rise. I mean, I'm not an economist, but you can put that picture together better than I can. Drought in India has a very strong historical perspective. The fact is that until 1947 and before that, drought was almost tantamount to famine. And if you read old British accounts, especially in the 19th century, if there was a drought, there would be floating bodies in the Ganga. We were a very poor country, we still are a very poor country, but where majority of the agricultural labor who does not own the land, really the fortunes, especially before irrigation happened, before the green revolution happened, the swing was all about drought or no drought. And famines are in history of India to a great extent has actually been the history of famines. And this has been studied for over 130 years. Now, when the IMD talks about a normal number, where does it come from? The normal average for the months of June, July, August, September is 886 millimeters. Now, this average is an average which is based on meteorological about 500 or so meteorological stations over the years. It was an average which is kind of continued since the British. But the monsoon pattern generally has been tridecadal cycle. So, if you do an accumulation of all the tridecadal cycles from 1901 all the way down to 2016, you will see that we are going above and below the average. So 1901 to 1930, 868. That between 1931 to 1960 actually shoots to 929. What this means is that the pattern. Now, when I say pattern, we really haven't understood the dynamics underlying that pattern. But these are raw numbers to play with. You've had 30 years of tridecadal cycles of high frequency droughts, followed by tridecadal cycles of high frequency excess rainfall events, and that is something that you kind of see in that fluctuation. If you see in the last 30 years, between 1991 and 2016 or so, it's the lowest of them all. It's you're off the average by about -5%. That's a significant shift that has happened. You would also see in the alteration, it is said that after 1985 we were supposed to get into a regime of high frequency of excess rainfall events. I'll also come and define what is a below normal and above normal, but that has not happened. So the normal itself is something, and I'm not saying this, it is out there as a debate, but the normal itself needs to be seen in perspective. Now, this is 886 millimeters of rainfall between 1901 to 1930, where your total population was around 300 million people and you were in a rather agrarian economy. You multiply that 3 times, your per capita consumption going up in normal is the same, and rather it's gone down by -5%. So, it is just about perspective. Also, to define, and unfortunately I haven't made a slide for that. If you are below 90% of 886 millimeters, that is defined as a drought. If you are between 90 and 95%, that is considered a below normal. If you're between 96 to 104, that is considered normal. And if you're 104 to 110, that is above normal. And above 110 is what is considered as excess rainfall events. So to give you a sense, 2016, and how many of you thought it was what kind of rainfall was it? Do you have a sense?
Your forecast was that it would be deficient.
No.
No?
I mean, do you know what it was last year?
I think slightly deficient.
No.
Okay.
It was normal.
Okay.
So the sense of normal or above normal depends how, as an Indian, where we are and what we experience, because there is so much variability in the rainfall, both on a spatial sense as well as a temporal sense. So, but now when does trouble break out? Trouble breaks out when you start slipping below 95. So to give you a sense, even though 97% is a normal monsoon, you cannot say that to somebody in Karnataka and Tamil Nadu. Tamil Nadu has had the worst drought in 15 years. Karnataka has had 3 straight years of drought. In a normal monsoon scenario, where you have GDP numbers, where you have tractor sales, where you have motorcycle sales, everything going up. Because you get a good monsoon, you also consequently end up getting a good Rabi. Because you had a good monsoon last year, you're not, apart from the Tungabhadra Dam and Nagarjuna Sagar, all your other reservoirs are able to pull you through your summer. So that is how these indices or these numbers have been built over a period of time. In my experience, A good monsoon, which is well distributed across all geographies, is about 102. In every normal year, there are areas that are under drought. In every drought year, there is about 20% of the country that is under excess. Okay, so a drought or normal or below normal means different things to different people until you sit in Delhi and you have to average it all out. You know. So what is 886? Where does this number come from? This is a system that has been devised over almost 60 to 70 years. You take 500 stations. These are observatories of the IMD. Observatories, now there is a very strong method to this, and it's an international system. These are synoptic stations where observations are diligently written every 3 hours, round the clock, and transmitted over what is called the GTS. So you have these 500 observations that are taken. Then you find district average rainfall. You do subdivision wise rainfall, and then if you look at the map, these are not state boundaries. These are meteorological subdivisions. You know, you look at Maharashtra, or if you look at erstwhile Andhra Pradesh, broken into 3 parts. Okay, because these are, from a hydrological perspective, homogeneous regions. Agrometeorological, hydrological. I mean, I'm not really an expert on this, but that is how the division is. Rather, sometimes I feel, again, I'm digressing. These are the natural state boundaries. You know. Now, if you see, each state or each region has a different weightage, because Northeast has such a high normal. Its weightage is only 3.0 or 2.5 or 2.2. Rajasthan, which is a big state with a low normal, has a higher weightage of 5.8. So that is how these numbers and how that distribution has been devised over a period of time.
So if Rajasthan gets a little above normal,
then it pushes the average.
In absolute terms, it would be nothing compared to, let's say, the Northeast.
Yes, yes.
But then it has more weightage.
On the natural, yes, on the normal monsoon. So the amazing thing about Gujarat and Rajasthan is that because their normals are so low, you could have a situation that by till mid-July people are complaining about drought, and in one day it shoots to above normal. Jaipur has gone from a minus 50, okay, or Jaipur region, eastern Rajasthan, to plus 200% overnight, because that region had 164, 185 mm rainfall. Whereas in Northeast, Cherrapunji in peak monsoon can be 500 millimeters for a couple of days, but doesn't move the national average. So that is how this, and
Cherrapunji itself goes dry in winters.
Yeah, but I mean, this is summer rainfall. So, Northeast has these, if you look at the rainfall numbers, Northeast will be 600, 300, 400 days on end, but the national average doesn't move. It's a very smart system. It's been there for a long time. The challenge in India is, how do I get hydrological information, precipitation information on a high geographical resolution? Because, if in peak, say, monsoon time as it starts, so one guy will say that it hasn't rained and the other guy will say I'm okay. In Nasik will be okay, but say Sinnar will not. Okay, and there'll be, and in India our districts are huge, and they are also the topography is massive. You go to Mahabaleshwar, so there is a lee side and there is the other side. So one side gets a lot of rainfall, the other side is absolutely dry. So the idea was, can we make a better average by creating a finer grid over a period of time? So there are 2 data sets. So one is this one, which is the which does the averaging at the subdivision basis and uses only 500 stations. So the criticism is that Odisha is represented only by 1 or 2 stations, a state as big as Odisha. So they decided to kind of take every data set. So there are 537 IMD observatories. There's a CWC network, which is called Hydromet, which is about 522. There is an Agromet network, and then state departments, especially irrigation departments, have had observatories over a long period of time. Now the reliability has been in question, but the system has been there where somebody has been noting down data for over 50 years. So this total number comes to about 6,329, out of which about 1,803 stations have a minimum of 90% data availability. So that gridding of 1 degree by 1 degree, which comes to about 110 kilometers by 110 kilometers, is based on what is called analysis data, which is created almost every day. Now, the point I'm coming to is that actually in common sense, this is the way we should be, this is how we should be moving, and this is how we've moved. And the government and the IMD has done a fantastic job of doing this. The problem is that the two systems have not been reconciled. So I have picked out, years in which the gridded data, look at the difference, see, just stare at this for a while and this will make sense to you. The difference between gridded data and station data. So if grid data is minus 9.9, station data is minus 13. There's a difference in category. One is a below normal and one is a drought. Drought, minus 10. One is a drought. Okay. Then let me come to 2012. Now this is a very interesting thing. 2012 grid data says that this is 103, which is a normal year. But if I look at the 500 station data, it is minus 7, which is a below normal. 2012 is the year in which Maharashtra got the worst drought in 100 years. So this is when it comes when the politics of measurement, our scientific institution need to reconcile these two data sets, because but a lot of times it presents a completely different picture. And I really don't know why they have not. Why either we do grid, or we do station, or we move to some kind of a hybrid between the two. Ideally, we should be doing grid. Now let's talk about the mystery of the onset. Okay, now we have always, and this is going to come now. The IMD is going to give an onset date, and IMD is going to announce an onset date. Now there is an objective mathematical criteria for the onset. Okay, if after the 10th of May, 60% of the 14 stations in Kerala get a rainfall above 2.5 millimeters for 2 consecutive days, the onset is declared on the second day, provided B and C are also fulfilled. There is the westerlies. We should descend. Westerlies are winds that should descend to a level of about 600 hectopascals. Just to give you a sense, 900 hectopascals is surface level. So you have to have these westerly winds coming in at 600 hectopascals. In that box of lat long, it's a 55 east and 80 east, and should be at the order of 15 to 20 knots. Okay, at the surface level. And then the last one is OLR, outgoing long wave radiation. This is measured by satellite, and this should be of a particular value in a certain box. And I guarantee you, if you take 50 years of data set, not all of these conditions, if you objectively test them, have actually ever been satisfied.
I mean, all three together.
All three together. Yeah. Okay. So the question is, and there is no answer to this. What is the difference between a pre-monsoon and a monsoon? Okay, there are hundreds of answers. What I'm coming to is, if you notice, and you might hear this year, if the monsoon is slow and weak, then they will say that the monsoon air mass has reached, the monsoon is coming. That doesn't make sense, because the onset of the monsoon talks about 14 stations getting 2.5 mm rainfall in 2 consecutive days. So for example, Mumbai, how if you are a monsoon watcher, one of the things you will follow is called an NLM. It's called the northern limit of the monsoon. Okay, so this is a line that is drawn. First, it's drawn in Kerala. It's like a U shape going into Calcutta northeast, and it's like a skirt that covers India all the way into Rajasthan, and after Rajasthan, it actually goes into Pakistan. We were one British India at one point of time. But that drawing of the line, if you follow this objective criteria, and there's an objective criteria as it climbs the country, you will figure out that as long as it is raining, nobody's talking about it. When it starts going dry, you'll see suddenly the line being pulled. It's my theory, and so sometimes there's an argument that the monsoon onset happened 20 days after it was declared, and sometimes there's an argument that the monsoon actually started in the last week of May, because Kerala is going to start raining from the 22nd of May. The objective criteria is probably going to be satisfied around the 2nd of May. But now there's the other problem is, if I say it is 2nd of May, IMD doesn't appreciate it. So they will come up with another number.
2nd of June.
2nd of June, sorry. 2nd of May is passed. So there is a lot of this, trading, and the onset of the monsoon, if it is on time and is strong, the stock market goes up. So far, it was always that psychological thing that, okay, monsoonal winds and precipitation have reached Kerala, and if the 10th of June you get a big shower in Mumbai, the perception used to be that this monsoon is done. Now, let's all turn into, meteorologists and forecasters. So, if you analyze 116 years of data sets, okay, So there's 20% of all the years have been deficient, which is, drought. 10% are below normal, 34% are normal, above normal is 22%, excess is 14%. So effectively, if I was a forecaster over the last 116 years, and every year I had to make a choice, I would just take 34, 22 and 14 and say that it'll be either normal or below normal. 70% of the times I'll be right. So if you take climatological averaging, monsoon should work out over the last 116 years 70% of the time. So, and the other thing is, monsoon is never less than minus 30 as a baseline. It has never. So you will always, in every year, you will get the monsoon, you will get 70% of your rainfall. And if
I may interrupt you, in 1987, it failed totally.
But it was still above 70%.
I see, because there was not a drop of rain in Delhi.
But Delhi is small.
Not a drop of rain, but it was still 70% of the norm.
Yeah. Minimum is you will get 70. The worst case scenario is 70%. I think the worst monsoon is a minus 30 in history. So you will get that rainfall. So there is a level of inbuilt predictability in the climatology of the monsoon itself. Okay. So it is less of a. The problem is to find the dry years, droughts, and it is because it's only 20%. Which one it is has been the challenge. So, let's ignore SkyMet. So now, this is the report card. So we basically back tested our algorithms, and then we took the IMD history over the last 29 years. So you look at 14 out of 29 years are straight out success, 13 out of 29 years is straight out failure, and 2 out of 29 years is what we would call moderate. 18 out of those 29 years was a normal forecast. Now coming back, I don't know if you've been following the monsoon forecast of 2017. We have gone for a -5. The IMD has gone for a -4. -4 of that number, of this number. This number, 886. Okay. Now, it is only a 1% difference, but the storytelling is very different. I'll tell you why. Below normal means, and if you look at a Business Standard article that came out a couple of days ago, where the government has been quietly telling state governments to prepare for erratic or maybe below normal monsoon. Versus 96, which is a normal, but it is the lowest number. Did I break something? Sorry. So it is the lowest number in the normal. Okay, and if you look at the percentage of probability, they say 38% chance of normal. The question everybody asks is, what about the rest, kind of 60%, for which they haven't told you. So if you look at now I've given you these two perspectives because if you look at all the international models out there, and these are 6 of them here, there's another 6 later, they're all telling you that there's a lot more yellow. Yellow is for less and green is for more than green. If I average it out, it is coming to anywhere between -4 and -5. So the story is that where we are standing today, and if we have to take a call, this monsoon looks like it is going to be below par. But if I have to tell that story and not get people to panic, because we've had, and this government has been unfortunate because they actually ran into 2 back-to-back monsoon, back-to-back droughts in 14-15, and you've had the Karnataka and Tamil Nadu droughts in
even last year.
In the last year. How do I cherry pick my data and present it in a way in which I actually exhibit? This is my theory, okay? Optimism, but I'm making space for failure because I'm only 1% away from below normal. So effectively, our forecasts have an error of ±5. So if I'm 95, I'm covering between 90 and 100. And if I am 96, I'm covering between 91 and 101. Okay. So that is how, so it depends. So what is the story that the state needs to tell the people? So I think it's a very smart story because we live in very polarized times. So I have been called anti-national on Twitter for saying below normal. I don't know what that means. But
it's got to be backed up by data.
But it's a mathematical number. Mathematical numbers don't look for. And anyway, but if you give a 96, if you look at really hard that number, the government is basically telling you, listen, there's a chance this will be good. There's a significant chance this might not be good. So that's why it is the lowest normal value. Now I don't know if it is the government that is telling you that, because the government here, there are 2 levels. There is the IMD and then there is PMO. Or is that the IMD telling the government something so that it is able to, because they're kind of competing with us now, be closer to what might happen, at the same time satisfy needs of governance? I don't know. But it seems that if you're 96, you could also be 95. And if you're given 38% probability of normal, that means what is the probability of below normal? And if the probability of normal was so good, then the what is your above normal probability? I don't know, So that is how I would kind of consider this 2017 monsoon. Is the forecast number the 886? Okay, now the 886 of June, July, August, September, split into 4 months, has this distribution. June is minus 17. July is the most biggest one, 33%. August is 29%, and September is 16%. That makes up, so significantly. In India, we find ourselves in a difficult situation if we get a long dry spell in either July or August. You can survive with a bad June. You can definitely survive with a bad September. You cannot survive with a June that is below par by anything more than 6%. It creates a problem, and I have seen it so many times. It's like elastic that at some point just snaps. So that is in terms of the temporal distribution. Okay, now this is a debate. I am on the other side of the debate. I think that 886 number is a good starting point for somebody who doesn't come from meteorology to start getting into this. But so Dr. Makran and Dr. Ali said we should talk about this, that maybe our monsoon forecasts need a little bit more perspective. So if you look at 1997, and if you look at the yellow parts, okay, all these yellow parts were below by minus 20%. That is significantly below. If you look at 1998, which is about 100%, look at how lopsided it is. So if Rajasthan, Tamil Nadu and Karnataka are okay, Eastern India, parts of Eastern India are lower. You look at 2003, which is 102, you've got these red parts, which are below 50%. And if you look at 2005, which is 99, you have parts of Northwest India. As I said, there are, even in a good monsoon, there are parts of the country that are significantly below. And in a bad monsoon, which we don't have now, I think I should have added, there are parts of the country that are significantly above, and for some strange reason for which is purely only chance, Vidarbha, Rajasthan and Gujarat have been doing relatively better than other states in drought years. The states that are suffering now more often than not is Marathwada area, Karnataka, Kerala, Bihar and the Northeast. And Northwest India also, I think the variability.
Gujarat as per this.
No, this is just 1 year. Gujarat is also not that badly off. Now, coming to the, who created all of these understandings data sets? So, our system is British. It was built by them. The first Director General of the Indian Meteorological Department, Henry Blandford, talked about order and regularity are as prominent characteristics of our Indian atmospheric phenomena as are caprice and uncertainty those of European counterparts. What he is looking at, especially in this perspective, I know what he's talking about. Why, you hear this all the time. Why is it so easy to forecast the weather in the US and Europe? Why is it so hard here? It's very simple. We are a hot tropical country. They are a temperate country. They have, that's why he's talking about caprice. Indian definition sticks to the NOAA definition. So they will say that until I see 3 quarters, until the Americans don't declare, I am not declaring. So therefore you will see this argument that El Nino will come only in the latter half of this thing. But Sika's theory always was that I don't need to wait for it to do damage to me. That's the theory. Now, official reaction. This is probably the lighter part to our existence. I've always called ourselves the bastard weather service, and we have been treated as such, but that's fine. So in 2014, El Nino was on the horizon. We went to town with it in January, and this was the reaction from actually a very good scientist. And I don't know where this comes from. So we said that there's an El Nino, we need to be careful. Like I've said this year. It is in the US and Australian interest that agri-commodities and stock markets in India come down. They are spreading rumors, that is us. People will start hoarding and might start creating artificial scarcities. Don't heed their advice. So you can't think like that in this day and age. Data is out there. This is something we've got a big project in Maharashtra where we are putting up 2,065 automatic weather stations, and this is how we have been described. How is IMD coping with competition from private weather forecasters? As far as services is concerned, there is no competition from anybody because nobody can have the knowledge base or system support to render services of that magnitude. Now, our forecast in 2015 went horribly wrong. Okay, and the reason was because we probably one of the things that I wrote was that as long as we were sticking to El Nino, we were okay. We thought that it was the second El Nino. After 14, 15 was also El Nino. Since you've had one, the second should not affect you that much. Also, the it is probably because maybe I was younger, though it is 2 years away, but in the level of what you've gone through in the last 2 years, dealing with a problem like this makes you, I don't know, much more mature. Even when you talk about, say, the Bureau of Meteorology or IMD or NOAA, climate sciences are probably 50 or 60 years away from delivering perfection. How look at other things like medicine. So, in those imperfections, there will be times that you will get completely wrong. See, the problem is either it's drought or not. There is no middleware, and the climate dynamics of the CFS2 had indicated to us that it would be a normal monsoon. Theoretically, it was also making sense. Also, that back-to-back droughts are so rare. By the way, the IMD has not declared 2014 as a drought, even though it has declared 2015 as a drought, and they're very similar. One is 88% and one is 84%, I think. And that's the politics part of it. They call it deficient but not drought, but 2015, according to the same standards, is a drought. So that was a learning for us. So therefore, we are a very El Nino sensitive company.
IMD was predicted this year monsoon won't be there, and soon after 20-25 days they are changing their predictions. So
they have gone from -4. I don't think they've changed it yet.
it came in the paper.
I mean, if you could be specific, I generally am on top of things. I don't think they've changed it, and they will not change it so soon also. They're going to wait. I think the next IMD forecast will be on the onset of the monsoon. Yeah.
So, Jatin, I had a question. I'm of course not in this area, but I had a question from a statistical point of view. If your predictions have a 5% error, standard error, and given the spatial variability across India, what does it actually mean to get these forecasts that are drought or above normal or excess rainfall? Because those are being made on some arbitrary cutoff of below 104, something above 104, something else. When in fact that's a continuous distribution, and there's error in that, and I cannot predict outcomes in any particular area from that overall number. So, in your opinion, how is that prediction helpful?
You see, it's very helpful because you're also where are you coming from? So, for example, I don't know what's going to happen next year, which means, is there a drought next year? Is it going to be above normal? There are two different scenarios. So, let's say, let alone a farmer, let's say you understand farm, right? So I'm talking to SN Pass, they have a lot of hydro units. If it's not going to rain, how am I supposed to, that's where the underwriting comes in, for debt or for power, whatever. So how should I resource myself? So if there's an El Nino year, then maybe I'm looking at a hot summer, maybe I'm looking at an extended summer, maybe I'm looking at many more hot days in July. So either I do nothing and I take the normal. So every year I will do the same thing, or I take my chances where my resource distribution is such a way that I actually skew it in the direction of the forecast, not going whole hog because we know that. But if you skew it, that's what my business is built on the direction of the forecast, you're better off than assuming an average. Okay. Now, when you say that you cannot get a spatial distribution at a district or tehsil level, but you're able to find what I call spatial red spots. So the spatial red spot for this year is our region, Northwest India, from Delhi to Gujarat to maybe parts of Maharashtra, or the north or the western part of this country, as opposed to the eastern part of this country. That trend for last year, if you look at the forecast that we gave out last year, one of the things we said was that most of the countries find that the part where Karnataka, Andhra, and Tamil Nadu meet, there might be a problem. I cannot be more specific than that. And you can see that, I'll find that statement. more or less come there. Now, if you're a decision maker in Delhi, you should have, because it was see what happens is, in an El Nino year, most of India is bad, but Tamil Nadu is good. Like 2015, Tamil Nadu had 3 depressions and one of the worst floods. Okay, 2016 was a La Nina, which is supposed to be good for us. Tamil Nadu completely failed. If this is an El Nino year, if the El Nino sustains, I don't think this El Nino is going to sustain that long. If the El Nino sustains, then Tamil Nadu should be able to pull through this year. So I am more confident of Tamil Nadu pulling through than India as a whole not pulling through. But if I have nothing, I would say that India will almost pull through, but there will be problems. So I mean, now if you have nothing and you have this, and I tell you that I have about 65 to 70% chance of, am I right? And what is the instance in which I am wrong? Then you can resource. That is the reason why the government is resourcing today on that basis. So who are the resources? So you could be a stockbroker when you punt against agri input as well as say Mahindra Finance or whatever, because I don't think tractors can pick up. You could be Food Corporation of India. You could be Minister of Finance. You could be, of course, managing the grid, and looking at trade and looking at spikes that might come in. So it's not about what can happen, what cannot happen. So there is a 0% chance of excess this year. That is done. It's almost 100% correlation. Now that's a good start. Yeah.
Just following up on that question. So it would be better if the government gave, instead of a single number, but gave a little more detail. And that's actually, and I'm wondering what is the political reason for not.
Even it escapes me, because a country like India can swallow demonetization. A country like India can take a bad warning.
Yeah, in fact, it would be better for the government, because it's not a question of completely right or wrong. It's and it's more useful for the people, because you know that these areas are likely to be stressed. So you can those folks can pay attention.
They did this in 2015 and they were right about it, I have to say. I don't know why they have not done this in 2016. It's there. Our scientific community is absolutely capable of doing this.
But you said they are telling states, just not media, not the public.
Yeah, no, it's a business line story. The media has picked it up, but the unofficial thing is that be prepared that the monsoon might be below par. That means 90 must have warned them.
Is it because they don't want to generate panic?
I don't understand, but Indians don't panic anyway. I said, people, I don't know where this comes from. Hoarding will start. Hoarding happens anyway. Our policy makers are not policy practitioners. So I don't know. I almost find Hindi mein word bachkana for not taking it and going ahead with it. I don't know where this comes from. Yes, sir.
Why does climate varies in small degrees from year to year? Apart from the temperature, the emissions of the sun varying slightly from year to year. Leaving that aside, is there a factor endogenous to the Earth which brings about minor changes from year to year? And I don't mean human activity, some non-human activity within the planet which brings about changes from year to year. Is there such a factor?
Sir, a book has come out. I think everybody from Sweden. It's called Indica, written by a friend of mine. It's about the natural history of India. Natural history of India, not the world.
No, I mean...
I'm coming to that. So, volcanic emissions. It could be, the Earth has changed over a period of time. Now, an annual, on the scale, you might not be able to calibrate it. But if we look at, say, 100-year cycles, 200-year cycles, sure, the Earth has cooled, the Earth has warmed in its own way, for a variety of reasons. Because most of all, it is the interaction between the hydrology and the land features that has been happening. But in terms of an annual scale, most of the changes that we are seeing, and we have another PPT, I don't think we have time to show it, you can clearly see it as anthropogenic. So, for example, you see a spike in carbon, and you see a spike in the Chinese economy. Straight away, when Asia grew, the Earth heated up even faster.
But I don't mean these human activities.
On an annual scale, I'm not sure if...
Not annual, are there non-human factors
Of course,
within the Earth?
That's how the Earth has been created, no?
But it's more the sun and the impact of...
I mean, say volcanic explosions, lava, stone, your greenhouse effect, the basics.
So the seismic activity.
The seismic activity, our poles, all of that goes into our Earth system. It keeps on changing. So, I mean, for example, why aren't mammals as big now as they used to be? And this is not my field, okay? So I'm completely I'm not an expert. It's because the air is only 21% oxygen, 72% nitrogen. That composition has been changing. The reason why trees were bigger and mammals were bigger because the oxygen content in air was much more, and which got compressed. So you have fossils of centipedes in Himachal Pradesh which are like that long and this big. A centipede is not this big. I mean, that's because the earth system has been changing.
Jatin, I have a
Yes,
question.
sir. Yes, sir.
Why are we so much dependent on foreign forecasting agencies like Weather Underground and AccuWeather and all, because they are supposed to be more accurate, and they give the correct, kind of forecast, other than going for IMD and maybe, we are one of the, private agencies in India, And so I would like to know, like why we usually, go for BBC weather, and find out कि हाँ वो तो it's very ठीक है कि बारिश आज होगा, whereas IMD cannot tell, कि नहीं आज बारिश होगा कि नहीं होगा, so.
सर इसका जवाब मैं हिंदी में दे सकता हूँ. How many people are comfortable with it? इसका जवाब हिंदी में होना चाहिए. ठीक है. This is another problem. This is a problem. I'll speak in English. Of India is a country, and this is completely different from science. Okay, it's governed by clerks. Okay, a clerk whose job is to stop everything from happening rather than make it happen. I'll tell you a simple thing. When I was growing up, before cable TV came to India, we had only got Doordarshan. You could have asked, why don't we have all these channels? Why didn't we have it? And why did we have it is the better answer. We had it not because the government came up with a regulation that we should liberalize. It's because Gulf War happened, satellite television came, and they could not ban it. Why? Because downlink was legal, uplink was illegal. And it happened. And then they were forced. The other example I'll tell you is Uber and Ola. Uber and Ola, when they started, were completely illegal services. They had no registration. It scales, it happens. The government never wanted it. E-commerce in India is illegal. Okay, they never allowed retail to happen. So, अगर आप हर चीज को बंद कर देंगे, why don't we have private space launch in India? Why can there be no Elon Musk in India? आप बंद कर देंगे उसको, तो वो इंडिया जाकर वहाँ काम करेगा, फिर आप जाकर उसके you ask him and you get a hall full of people to listen to him because you couldn't do anything. It has nothing to do with our capabilities. You are not allowed to do anything. The state is preponderant. It owns everything. How can you? I do this by chance. Frankly, if I had to do this again, I would have never done it. It is so difficult. It is actually very difficult. My father is here. He's been doing this for 25 years. He was a vendor to the IMD. That's how I picked this up. So you can't GM crop जो भी है नहीं हो सकता, बंद कर दो. But before you even think about it, cogitate it, बंद कर दो इसको. कुछ भी हो उसको पहले the first reaction is इसको बंद कर दो. So I'll tell you another example, and this shows how why we will never be China, because China is shockingly practical. If you fly in China, all of Chinese airspace is governed by the Chinese military, all of it. There is nothing called civilian air traffic. There's a company in China which is the single biggest manufacturer of drones. It's called Phantom, DJI. $1 billion in revenue. And it's China is a nation that parinda bhi par nahi mar sakta. And mind you, there is no Google and Facebook in China. That is how controlled. But they are practical in supporting a country that can build drones and export it to India. India, so-called open democracy, private flying, the moment drone can ban it. So if I'm a drone manufacturer and I can test it, how can I become a Phantom DJI? And mind you, it is not only I am banned. One government organization goes after another government organization for stop it from flying. We are a country of clerks. I keep on saying this. Our political leaders do not know the decisions that are being made under their noses. So you will never have these things. And I see it. I mean, IMD has tried its best, but so the reason why there is one Weather Underground or weather.com, there was a weather television channel in the US for 60-70 years. That over a period of time created technology. The government, I'll tell you a simple fact. In America, NASA comes under the Department of Commerce. It shows you their thinking. Can the Indian Space Organization ever come under the Department of Commerce? वो नाक की बात हो जाएगी. Okay, because it helps them spread their technology. Okay, so for example, if NOAA is created, the idea is that NOAA has to share all the data. The IMD, which is actually better than many other organizations in sharing data, because of the internet, because of Weather Underground, only started sharing data from 2007. How can a company innovate if there is no data? So I started innovating in 2003. Okay, and then we are here where we have the single largest automatic weather station base. We've got lighting. You go to my website. I am able to catch every thunderstorm in real time. We've got 15 drones. We are sensing leaves. It all happened because there was an opening for somebody to do something with it. And C.V. Raman was probably the last Indian scientist to create a company. It was him or G.C. Bose or C.V. Raman who was a partner in a matchstick firm. Okay, how many scientists, entrepreneurs do you find in this country? From the domestic setup, जो अमेरिका से पढ़ के आने वाला नहीं, यहाँ का, from a BHU or whatever, none. If Indian science and scientists are protected and they do not do applied sciences which is commercially viable, you will not get the weather wrong. Yeah.
So I have, thank you very much. That was a very, very interesting presentation. But I want to kind of go to the other side where you talked about weather stations. So when you talk about sub-district variability, there's also so much within that district itself. So one part gets rainfall, one part does not. And from your presentation, I understand there's very few weather stations and also so much missing data from there. On the other side, you have a lot of weather-linked, monsoon-linked insurance programs coming up. So what are these deficiencies in this measurement that have to be overcome for that system to be much more reliable?
We are, and not to say this in an arrogant way, we are the biggest one now, 6,000.
Right.
We are the biggest settlers of weather claims. We also provide data for underwriting. I understand this space completely. To give you a sense, the National Weather Service in the United States has 7,000 automatic weather stations across the country, in a country 3 times the size. India, if you combine all the networks, is already at 11,000. So we've got huge numbers now.
Alright, so this is everyone.
Everyone, us, NCMSL, whether it is IMD, the network is big. Now the problem is that the government doesn't think that any network apart from its own network is legitimate. But I have convinced the state government that I am legitimate, and you can, so we are the de facto in Gujarat, Maharashtra, Rajasthan, probably in MP, and all these big states. Okay, so they are forced to accept this. Now, theoretically, the need for a high density weather stations is actually wrong. It helps my business, but as a scientist, I will never argue for it, because what you need is an interface of weather stations, radars, and lighting sensors. Because radars, you're able to get liquefied water in real time, and once you analyze it and spread it, your rainfall distribution, you get it at every square meter. And the fact is that data is already there, but the IMD does not accept it. Why? Because for the IMD, maintaining radars is a problem, and buying them is a problem. See, have you ever undergone a government procurement process? I think it's a must-do for self-flagellation in this country. It is impossible for the government to buy even a eraser or a pencil. Okay, this is what I'm saying. Country of clerks. A country of clerks, and their actions then come into this whole narrative of automatic weather stations because the government cannot procure equipment, even if they have money. That is a practical problem. It will mean, and this, by the way, the Ministry of Agriculture, the Civil Aviation, Disaster Management is all saying, let's get all this network under one roof. Let's get all these people under one roof and create one universal data set so we don't have to spend so much money. But at the end of the day, even I can't deny it, the IMD has to take the lead. That's the problem.
This is the question of space giving, if I'm not wrong, like IMD is not very much comfortable.
Why IMD? IMD is a good organization, sir. Criminal organization is Geological Survey of India. Survey of India. The people who work on topographic maps who will not release it to you. Central Pollution Control Board. When you will not lose your job, when you are allowed to get away by not giving away data and lying, what is going to happen? IMD is actually IMD over the last 5 to 10 years has, go to their website, they are actually giving away so much data. I think they need to be appreciated more for that. And if I take out and mind you, this is not an Indian thing. This is a developing country thing. India is that way still better. You go to Pakistan, you go to Sri Lanka, you go to Cambodia, Vietnam, you go to China and the CMA. This whole thing of not giving data, not sharing, not innovating is much stronger. But anyway, for example, how many people know that where is Geological Survey of India located? Calcutta. Okay. Geological Survey of India was created by the British to figure out how much coal was there. Today they cannot even figure out if there is gold or uranium or anything. Nothing ever comes out. There is no outreach. There is nothing. Why? Then fire them. Why? In government, it's not government. As long as there's a monopoly, when people cannot lose their jobs, nothing's going to change. And that's my theory. We have the founding fathers of this country. Do you know there is an organization called the Geophysical Research Institute whose job is to measure gravity across the country? Gravity is very important because it gives you mineral density, shale oil. What is it doing? Do you know how difficult it is to get a topographic map of Mahanadi River and is treated as a state secret? If the United States can give away Landsat data at less than 1 degree resolution online for the rest of the world, आपको महानदी का map देने में तकलीफ हो रही है? And not even to me. For example, I have seen forest departments and revenue departments fight over maps. Who are the people settling those battles?